Without further ado, let's welcome Guy from Fhenix to tell you all about FHE and coprocessors. Please give him a big round of applause.
Thanks. How is everybody doing? I'm the last presenter before lunch. I hope to keep this entertaining, so by the time we end the conversations, you're still here. As introduced, I'm the CEO of Fhenix. We provide L2 rollups and coprocessors based on FHE. I'm based in Portland. Every time I come here, I envy your weather and your basketball team. And with that, I'm going to start with the basics, and we're going to start building it from that. FHE is kind of a complex topic, and yet I'm sure you'll enjoy it. So starting with the basic, and I'm sure a lot of you know, but there is one thing that's common to all blockchains out there, which is the fact that they all need to do two things. One is they need to verify that a transaction is valid, and the second is they actually need to verify that a contract is executed correctly. And in order to do so, they need to reach consensus over public data. But what it actually means is that if you think about it, what blockchains does best is provide correctness of computation, and there is literally no privacy in the blockchain space. All data out there is public. So what does privacy even mean? And I think many people have that a bit confused. When we think about privacy, we think about two things. One is anonymity or pseudonymity, and the other one is confidentiality. So thinking about anonymity, it's the ability to hide the identity of the person that does the transaction, whether that's the sender or the receiver. There's been several projects trying to solve it, like Tornado Cash, etc., and not all of them ended up well. But what we're mostly focused is on a part which I think is more interesting, and that is confidentiality, which means the ability to hide the content of the transaction. So if you think about Bitcoin, it's the ability to send an amount and have that amount actually encrypted. But in the more interesting use case of Ethereum, it's the ability to do confidential smart contracts, meaning that the smart contracts can work on arbitrary data. So confidential smart contracts have been researched for quite some time. There's been a lot of resource invested in it, and typically they're being sold by using what's called privacy-enhancing technologies, or PETs for short. I will say that even though there's been a lot of research invested up until recently, there hasn't been yet a silver bullet to solve that, but we definitely see them becoming widespread in practice. And what does a confidential smart contract actually mean? It means that from a user standpoint, they can encrypt the data, they send the transaction is being executed on the blockchain, the state gets updated, and the output is returned to the user, and the user can actually see the output of the computation. So I'm going to give an example, and the example I'm going to give is like sealed bid auctions. If you think about a marketplace and you want to make a bid, you want to make sure that the bidding is happening in a confidential way. So let's see how the confidential smart contracts works in a sealed bid auction example. Think about a user that wants to bid on an NFT, or a user that wants to bid on an LLM model that will be a marketplace for LLM models at some point. So we have Alice. Alice will send her bid, in our case 5 ETH, but with a confidential smart contract, the bidding itself is actually private. And then we have Bob. Bob can't see what Alice bid, so he'll bid his offer. In our case, it will be 10 ETH, and so on and so forth. And when the contract time is done and it's being executed, there is a computation that's going to be done, and the winner will be announced on the public, and that's how we achieve a financial benefit for the higher bidder to get to win. So it all sounds great. Why hasn't it been solved by now? And there are several cryptographies that have tried to solve it. I think you've all heard about zero knowledge and MPC and TEs. We'll walk briefly about them. So ZKPs clearly are widely being used in our space today, mostly for scaling. They've been proven for quite some time, but ZKP, we have to remember, they're a proving mechanism. They're not a computation mechanism, which means that they can only offer single user privacy. The use case that we've just described of like sealed bit auctions cannot be done with zero knowledge, or it's very complex to execute it with zero knowledge. MPC, multi-party computation, enables you to run computation from multiple participants without them sharing the data with one another. The benefits of MPC, it's very fast, but MPC requires a significant amount of communication between the different parties, which is why you're seeing MPC widely used with custodian wallets when you have a limited amount of participants, but it doesn't really help you, and it's very slow to use when the number of participants become big. And the last one is trusted execution environment, TEEs. You can compute inside a secure hardware. It's fast, it's programmable, but the problem is that you need to trust the hardware, and they're prone to side channel attacks, and when there is an attack on the hardware, it becomes quite complex to fix it. So what is the solution? What is the end game? It's FHE, Fully Homomorphic Encryption. Yesterday, I was in Salt Lake City, and I met the guy that invented Fully Homomorphic Encryption, Craig Gentry. First article was done in September 2009, so I think we're almost like a bit over 15 years for that. FHE is amazing. What FHE does is it enables you to do computation on data while the data is encrypted. Everything that we've talked about encryptions, we know that when you encrypt data, it's meaningless and you have to decrypt it if you want to execute on it. With FHE, you can actually execute and compute over the data while the data is encrypted. And the reason that FHE works is because what FHE does, it maintains the mathematical structure of the data that you encrypt. So you can still compute over that, and the response will be encrypted, and only the user who encrypted the data originally can actually decrypt the output of it. So FHE has been out there for 15 years, always been associated with two significant problems. The first one is complexity. We are at this point in time where FHE is no longer complex. It's very easy to build on FHE. We have FHE VMs. Developers can build in Solidity, use the same tools, Foundry, whatever they use today to build on Ethereum, they can use. They just decide what they want to encrypt and decrypt. It's very easy to use FHE. Companies like ThirdWeb that we just saw support solutions around FHE. The second part of it that you can write contracts, that part of it will be encrypted and parts of it won't be encrypted. And that's on its own is quite simple. So I would say like somewhere like 20 minutes, you can already have like a developer starts to build a contract with FHE. The ramp up is super quick. So I said two problems. The second problem that's been associated with FHE is performance. FHE is complex. It's complex. It takes time to compute. However, there's been a lot of progression around FHE in both fronts. One is just making FHE itself faster and faster. Different schemes that are out there are coming and improving FHE performance. And the second part is FHE is computation bound, so better hardware means better performance. And there are already optimizations for GPUs, FPGAs, and even ASICs that are being built for FHE coming up in early 2025. So even with what we have today, FHE is definitely ready for applications today and just gets faster and faster. So the talk is about FHE rollups and coprocessor. So let me briefly walk you about how we use FHE in an FHE rollup. And it's no different than a generic rollup that we have out there today. The users, they encrypt their transaction inputs and they send it to the rollup. We then have the sequencer. The sequencer aggregates all of the transaction and executes them using fully homomorphic encryption. And we have the settlement that is done on Ethereum. So you have all the Ethereum security guarantees that are associated with it. If there is a request to decrypt the data, there is a component called a threshold network, which is taking the network key and sharing it among multiple participants for security. The threshold network computes, decrypts the data, And if there is a need to do post-execution validation, like fraud proofs, there is also a mechanism that enables you to run fraud proofs on top of FHE. So FHE Rollups already out there. You can test it and check the Fhenix testnet. Now, what if I have an L1 or an L2 or an L3 and I want to use FHE computation and I don't necessarily want to use an FHE rollup? The solution for that is a coprocessor. For those of you who may not know what a coprocessor is, coprocessor enables you to do computation off-chain. So a high-level flow is that you take a computation, you send it to the coprocessor runs the computation, sends you back a response, and the reason that you would trust the coprocessor is because the coprocessor would also send you a proof that the computation was executed correctly. And these proofs can be in a shape of a ZK proof, or some kind of a TE proof, or a crypto-economic proof that shows that this was executed correctly. So coprocessors are coming, and FHE coprocessor are actually coming in a couple of months out there. And the beauty of coprocessor is now any L1, L2, L3 that wants to implement encryption and run computation using fully homomorphic encryption can actually do that. And the flow is that the chain itself would get the contract, would send the contract with the computation to the coprocessor. The coprocessor itself would run the computation. That's basically step 4 that you see out there. If there is a need to decrypt, it will be sent to the decryption network. The proof itself, in our case, is done through eigenlayer, and then the result and the proof is sent back to the network itself, and you get encrypted computation in a very easy and efficient way. So what I'm going to do now is take a couple of minutes just to talk about a couple of applications, because it's all great. We have technology. The technology is transformational. But what can we do with FHE? So some of the use cases, I would say, are what I call like the immediate suspects. So very easy to implement. Clearly, confidential transaction is a mechanism that works very, very well. You want to send a transaction from user A to user B. You can use FHE to make sure that the transaction itself is indeed encrypted. Similarly, with voting for DAOs, that you want to maintain a voting that is private and not public. Sealed bid auctions, as I shared, for marketplace or for MEV. The right to do MEV extraction is something that has generated some interest. Compliancy pool. But for me, these are all like applications that make a lot of sense, but we're also starting to see interest in getting into the more complex and interesting use cases. One example is decentralized identity. The ability to get identities on-chain, and the reason that you can put a user identity on-chain is now because it's private. And once you have decentralized identity, you can actually now start doing on-chain credit scoring. And that's something that's missing today. And when you have credit scoring on how well the identity and the user behaves, now you can do efficient lending solutions for that. So all of that really generates like this, this snowball effect that really brings maturity and innovation and use cases into applications out there today. And then lastly, I'm going to take a few minutes just to talk about confidential AI, just because I know there is like a lot of interest in it, and most of the conferences they talk, people ask me about like verifiable AI and where AI is with blockchain and with FHE. So when we think about blockchains and AI, I typically like to look at it as we have blockchain and AI, and we have AI and blockchain. Blockchain and AI, or where AI can make blockchain better, we're starting to see solutions that actually enable, through machine learning applications, to build decentralized applications. Remember, this is still a small ecosystem, and the more developers, and even if developers are using machine learning-based solutions to build application, that makes a lot of sense. Audit smart contracts, build smart contracts using AI is something that we can see AI helping blockchain. But where things become more interesting is we're actually using the mechanism of FHE and blockchain to help AI-based applications. So a lot of what's happening today in the industry is we have what we call corporate AIs, right? All of the machine learning models are maintained by a couple of big participants. But there is a trend, and we're starting to see the shift for decentralized models, where we're going to see more and more models starting to build by decentralized users. How do you build the models? How do you bring data, which is private data, but you can still put it on chain and use that? That's a vehicle that will become super interesting about either making the models decentralized, but also making the models better by bringing data that you cannot bring today because the data that you have is private. So how do you bring the data on chain, and how do you use that to train the models? FHE will play a significant role in that space as well. Another space that's kind of interesting is what I call agent-to-agent transaction. In the future, and I don't think it's like in the far future, but maybe in the near future, users will have agents that would help them in their day-to-day online tasks. And having these agents-to-agents conversations can happen as transactions. And these transactions can run on the blockchain, and they can be protected through FHE. And then lastly is data authenticity. As we grow more and more, as we see more and more AI-based applications, it becomes challenging to know what data is real, was generated by human, or was generated by machine learning. Blockchains do a phenomenal job in doing authenticity, and we can start seeing marketplace for authenticity of data, and sealed bid auctions for marketplace, and just protecting it with FHE makes a lot of sense. So quite an exciting future. There is a lot of traction around FHE. If you're interested, you can come talk to me or Kyle, or just follow us on Twitter. That's it.